So good day. So this is analysis of, still on the analysis of determinate structures. So ito, deflection or the deflection of determinate trusses. So using virtual work. So what is the concept of virtual work? So the concept of virtual work is we have the external work should be equal to the internal work done on a structure. So external work is equal to the internal work. So as equivalent of this external work, we are to assume a 1 unit load multiplied by the displacement is equal to, for the internal work, that is the summation of the unit load, a unit load multiplied by the delta. So from your strength of materials, the equivalent of delta is simply equal to the force multiplied by the length divided by the area times the modulus of elasticity. But here, we are using S as to represent the value of the axial force per member of the given truss multiplied by the length. This is divided by the area times the modulus of elasticity. So therefore, we'll be having, since this is 1 and the displacement is now equal to, we have the summation of the unit load multiplied by the delta. Equivalent of delta is the axial force per member, the length, divided by the modulus of area times the modulus of elasticity. Or we'll be having the equivalent of delta as the summation of the axial force per member due to real load multiplied by the axial force in each member due to a 1 unit load multiplied by the length divided by area times the modulus of elasticity. So again, we have S, this is axial force due to real load, while U, this is axial force due to the 1 unit load. So for example, we have this truss loaded as shown. So for example, required natin dito. So let's say required the vertical displacement about point C. So based on this loading, so ano yung magiging movement ni point C? So we assume that to be downward. So again, kailangan natin, we need to compute for the axial force due to real load, the axial force due to unit load, then we tabulate. Alright? So all you have to do is we may use the method of joints or method of section. So proceed to do. Let us compute the axial force in each member due to real load. So medyo obvious naman ito. We have joint B and joint C carrying 4 kips both. So therefore, the reaction at D, this is the vertical reaction about point D to be 4 kips. Pareho na rin yun kay A. We have the vertical reaction about point A. So let's say this is A vertical is equal to 4 kips. So we may choose, let's say, proceed ako sa joint A. So we have at joint A, we have a vertical reaction of 4 kips. As you can see, this is 10 feet, this is 10 feet. So the angle of inclination is 45 degrees. So since again we have AF is a top chord, so pag top chord, it is assumed to be compression. This is for member AF. And we have AB. AB is a bottom chord. Usually for bottom chords, they are tension. So towards the joint is compressive force. Away from the joint is obviously this is tension. So this is by we have the summation of forces vertical equal to 0. Upward forces to be positive. At joint A, we have an upward force of 4 minus the axial force for member AF. Vertical component is sine of 45 degrees equal to 0. So you have the axial force for member AF So that will be 4 divided by sine of 45 degrees. So you have is equal to 4 square root of 2 kips. And this is under compression. So we need to identify whether the axial force is compressive force or tensile force. So later on, we are to assign the sign convention. Okay? Then, obviously, we can have it by summation of forces horizontal equal to 0. To the right forces to be positive. To compute for the force per member, this is member AB. So we have, that is AB minus AF. The magnitude of AF is 4 square root of 2 sine of 45. We may use cosine, pero since 45 degrees, pareho lang ang sine tsaka cosine. You have cosine 45 degrees equal to 0. So you have the magnitude of AB. I think this is obvious kapag 45 degrees. Same magnitude of components. So you have 4 kips, pero under tension. So we have those two members. We may proceed to joint F. So we have a joint F, we have the known value AF, 4 square root of 2. So we are computing for the value of EF and BF. So since this is upward, or it has a component upward, I'll be assuming BF to be downward. So this is by summation of forces vertical equal to 0, by upward forces to be positive. So this is 4 square root of 2. Okay, minus 4 square root of 2 vertical component. Okay, we have sine 45 degrees minus BF equal to 0. So I think this is a BF. Axial force, remember BF is the same as 4 kilonewtons, and this is under tension. Okay, remember BF. And EF, okay, by summation up. Summation of forces horizontal equal to 0, that is the same as 4 square root of 2 cosine of 45 degrees, okay, minus EF is equal to 0. So obviously naman si EF is the same as 4 kips, and this is under compression. So usually for top chords, they are under compression kapag ganito lang yung loading. So we have now member BF and EF. Okay, next members or next joint. So pwede naman natin isolve lang yung kalahati ng truss since we have symmetrical loading. Okay, so more likely AF is the same as DE, and AB is the same as DE since we have 4 kips support reactions at both supports. Then we have, let's say at joint B, we have at joint B, the magnitude of BF is equal to 4 kips under tension. We have member AB is also 4 kips. And under tension, we have the load 4 kips downward. So we have DC expected to be under tension. Okay, so if you are to observe forces at a joint of a given truss, if we have collinear members and they have the same magnitude, 4 kips. So this is 4 kips. Okay, we may assume that BC is also 4 kips. Okay, under tension. And that makes a member, yung member natin, the member BE to be a zero force, or a zero force member BE. Okay, since you have perpendicular or collinear, the load for kilonewtons is collinear to member BF or kilonewtons. So AB is collinear to member BC, so we can assume that B is already 0. A 0 force member. Then, okay, so again, I think we have member AF is the same as member DE. We have that is the same as, we have the 4 square root of 2 keeps, it is under compression since it is a top chord. Okay, this member is the same as this one. As you can see, we have 4 keeps. Then we have member AB will be having the same load as member CD equal to 4 keeps. Also under tension. Okay, so as we have a joint C, medyo obvious din sa joint C. Again, you have a joint C, you have collinear members, and okay, we have a joint C. We have here the 4 keeps load. We have member BC. So we have BC equal to 4 keeps, and for member CD is also 4 keeps, both in tension. So obviously, this load 4 keeps is collinear to member CE. So we have member CE will be the same as 4 keeps under tension. Okay, so there you have the axial force for members due to real loads. So next step is we are to determine the axial force for each member due to 1 unit load. So reminder, what is required? Vertical displacement of a joint C. So therefore, we assume that the vertical displacement of joint C will be downward. We are to place a 1 unit load downward at a joint C. So what about if the required is horizontal displacement horizontal displacement of joint C? Kung horizontal displacement naman yung required, edi maglagay lang tayo ng 1 unit load. Okay? I-assume that movement is to the right. But for this example, the required is vertical displacement above joint C. We assume that the movement should be downward, so we are placing 1 unit load downward. Okay? So we can have it by summation forces or summation moment 1 tayo for the support reactions. At A equal to 0, clockwise moments to be positive. So that will be the same as 1 times 20 feet minus the vertical reaction at D multiplied by 30 feet equal to 0. So we have the vertical reaction at about point D will be equal to 20 over 30. This is 2 over 3. Then with summation of forces, vertical equal to 0, upward forces to be positive, A vertical plus D vertical 2 over 3 minus the 1 unit load 1 equal to 0. So the vertical reaction about point A will be the same as 1 over 3. So those are the support reactions. So we have at joint A, this is 1/3. At joint D, we have 2 over 3. Then we compute for the support reactions. So at joint A, joint A, let us compute those values. So again, we have the summation of forces, vertical equal to 0, upward forces to be positive. This is 1 over 3 minus the axial force for member AF, sine of 45 degrees equal to 0. So we have the axial force for member AF. It's the same as the square root of 2 over 3. Alright, this is the axial force for member AF. Then summation forces horizontal. equal to 0. So this is the same as AB minus horizontal component of AF. That is the same as the square root of 2 over 3 cosine of 45 degrees equal to 0. So we'll be having the value of axial force for member AF. Babalik lang tayo, I think, sa 1/3. Okay? So those are the forces. So we proceed at joint F. So again, parang the same assumption of directions from dun sa railroads natin. So we have EF, it is assumed to be compression, and BF assumed to be under tension. So by the way, we have member AF is under compression and AB under tension. So we can have the values by summation of forces vertical equal to 0, upward forces to be positive. This is the square root of 2 over 3. Vertical component is sine 45 degrees minus the axial force for member BF equal to 0. So axial force for member BF is not equal to, I will be having that value equal to 1/3. This is the same as 1/3. This is under tension. 1/3 for member BF. Then by summation of forces, horizontal equal to 0, the right forces to be positive. We have the square root of 2 over 3 for member AF. Horizontal component is cosine 45 degrees minus EF equal to 0. So I think we have member EF is the same as 1/3, but this is under compression. Okay, so those are the forces for BF and EF. Now we may proceed to joint B. So at joint B, initially we have AB is 1/3, BF is also 1/3. So BC and BE are the other members. So what should be the assumed value of or direction of BE? I'll be assuming it will be under compression. So we can have summation of. This is the summation of forces vertical equal to 0, upward forces to be positive. That is 1/3. So again, this inclination is the same as 45 degrees. 1/3 minus BE. Vertical component is sine of 45 degrees equal to 0. So that's determine the value of the axial force for member BE. So this is the same as the square root of 2. We have square root of 2 over 3. So this is under compression. Okay, remember B. Then for BC, let's have it by summation of forces, horizontal equal to 0, to the right forces to be positive. Since that is bottom chord, assumed to be tension. We have BC. Minus AB is 1/3 minus we have BE, horizontal component, that is the square root of 2 over 3. Okay, horizontal component is cosine Pero pareho lang yun sa sine 45. Cosine 45 degrees equal to 0. So we'll be having the value of axial force for member DC this time. Hindi na siya pareho kay AB unlike dun sa real load kanina. We have a value of 2/3. And this is under tension. And it will be for member BC adjoint B. So we have, try natin sa joint C. Right, so we have joint C. Okay, nandito yung 1 unit load. Nalagay natin. We have BC is 2/3. Then, obviously, again, kapag meron tayong collinear forces or collinear axial force for members, they are automatically equal. So, which means the value of CD is the same as 2/3, and this is under tension. And the value, collinear with the 1 unit load at joint C, the value of C is the same as 1, and this is also under tension. Okay, so I think last member na yung hindi pa natin na-compute, that is for member at DE. So we may proceed sa joint D. Okay, so this is by summation of forces, vertical equal to 0, upward forces to be positive. We have 2/3 minus member DE sine up 45 degrees equal to 0. So we have the axial force for member DE. This is equal to 2/3 divided by sine up 45. So we have the value of 2 square root of 2/3. And this is top chord, so it is expected to be under compression. Okay, so I think those are the axial forces for all the members due to 1 unit load. So let us tabulate the values from the axial forces using the real loads and the axial forces due to the 1 unit load. So here is the tabulated values of the axial force due to real loads, then the axial force due to the unit load. So the length of the members is also needed. So we have, again, so you are to apply the sign convention. If the member is under tension, that will be a positive force. If we have the members under compression, we use a negative sign for both axial force due to real load and the unit load. All we have to do is determine the product of the axial load due to real load, the axial load due to the unit load times the length. So we have the first one is the same as 4 times 1/3. 8 times 10. So I'll be using 3 decimal places. We have 13.3333. Then we have the next one. This is we have 26. 26.667. I think pareho lang naman ito. We have 26.667. And then we have for member DE, this is negative 4 square root of 2 divided by negative 2 square root of 2 over. ay 3. I multiplied by the square root of 10 square root of 2. So we're having a value of 75. This is 75.425. And we have, okay, so for member EF, I think pareho lang naman dito. So positive times positive, negative times negative will be positive. So it's the same as positive 13.333. So since we have BE, meron tayong 0 bar force. So this is the same as 0. And this one is, I think the same kind. I remember BF, the same lang dito. It's the same as 13.333. And then, and for member AF, medyo magkaiba pala sila since ito. So we have negative 4 square root of 2 times the negative 2, negative square root of 2 over 3. And multiplied by the 10 square root of 2. So we have, this is 37.712. And then for the last member, this is, obviously we have 40. So we need the summation. Okay, we need the summation of the values of the action force, the unit load, times the length. So far, wala naman tayong naging negative value. I think everything is positive except for member BE na 0. So we have the value of, so the 246.47, okay, keeps squared foot. Okay, so we have the computed summation of the axial force, due to real load, the axial force due to unit load, then the length of each member. So how to compute for the vertical displacement of joint C? Okay, we have external work, 1 kip multiplied by the displacement, vertical displacement of joint C is equal to the summation of the axial force due to real load, unit load, the length divided by the area times the modulus of elasticity. So we having, this is 1 kip, the vertical displacement about joint C is equal to, this value we have 146.47 kip squared foot divided by the area. The area given is 0.5 square inch, and then multiplied by 29,000 KSI, or it's 29,000 kips per square inch. So 29,000 kips per square inch. If we have to do unit analysis, cancel yung kip dito. Kips squared, so cancel with siya, square inch, square inch. So we have now the vertical displacement about joint C is equal to, let us compute that value. As you can see, the remaining term will be in terms of foot. We have 246.47 is over 0.5 times 29,000. We have a value of 0.0117 foot. In terms of inches, it's multiplied by, let's say we have 12 inches is to 1 foot. The vertical displacement about joint C is equal to 0.017 by 12. I will have a value of 0.204 inch. And it should be downward. So as you can see, why is it positive? So the vertical displacement is downward but why is it that the value is positive? So which means we have a positive word or a correct assumption. So take note that a positive word when the applied force and when the force and the displacement have the same direction. That is a positive word. So, di ba yung assumption natin dito, one keep downward, assuming that the displacement is downward. So, which means, correct assumption, we have a positive work, okay, that is equal to 0.204 inch downward. Vertical displacement up, so it's